So what associative property states that if you take any three numbers or more, it does not matter how you group them together, it does not matter how you add them together, in what sequence, the net result is always going to be the same. So for example, if you add Q and R first and then add the result to the P, which is the first number, versus taking P and Q first and then adding the result into the third number, which is R, these two results will always be the same. Okay, so let's take some examples. Let's say I have a number 1/3 and I add to it the another number such as 2/3 and 4/3. Okay, three different numbers. I'm just trying to keep it simple, right? So when you look at this addition in this grouping, you will first solve whatever comes under parentheses, right? So that will be what? That will be 6/3, right? And then you will add 1/3 to it, and that will be 7/3. And likewise, what I do is I now take a different subgrouping of numbers. I just add 1/3 to the 2/3 and then finally will add 4/3 to it. Okay, so the first two number addition, it will give me 3/3 added with 4/3 and it will give me 7/3. Well, of course, the left hand is same as the right hand, right? So we say that it does hold true under addition. Now let's try to understand how associative property will work under multiplication. So if I take three numbers P, Q and R, if I take the subgroups of Q and R first and then multiply that with the P, it should be the same thing as taking the subgroups of P and Q, multiplying them first, and then whatever as a result comes out to us, we multiply that with the third number. And we are stating that these two results should be identical. Okay, so let's take some example. Let's say my first number is 2/5 multiplied with 3 and 5. Okay, all of these are rationals. This is a fraction and 3 and 5 are integers, right? Now when I do this, I find that this is equal to 15 multiplied that with 2/5 and this is equal to what? It is 6. Now let's do this. Let's take this number 2/5 and multiply that with 3 first. This is my first subgroup, and then I multiply that whole thing with the 5. Okay, so first what I get is this whole thing will result into 6/5. Multiply that with 5, it will give you nothing but 6. So yes, it does work. The left hand is equal to the right hand. Okay, so we say that the associative property also holds true for rational numbers under addition and under multiplication. Now let's play with some numbers to understand the subtraction and division. My new scenario is I have first number to be 1/2 minus 2/8 minus 3/8. Okay, and this is my first subgrouping. This is P, this is Q, and this is R. I want to evaluate whether associative property will hold true under subtraction. If it does, then it should be the same thing as P minus Q minus R, right? Changing the subgroups should not alter the result. In that case, I say that 1/2 minus 2/8 is my first subgroup and subtraction of 3/8 from that will be my whole new expression, right? So let's solve the left hand side first. 2/8 minus 3/8, it will be simply minus 1/8. And this will be under parentheses, negative sign outside, and this is being subtracted from 1/2. And what will be that result? That will be 1/2 plus 1/8. What you get is 5/8. Now let's take care of the right hand side. So in this case, first you have to subtract 2/8 from 1/2. What will be that? That will be simply 1/4, correct? And then you have to subtract 3/8 from this result, right? And when you do that, you will realize that this is equal to negative 1/8, right? This is equivalent to stating 2/8 minus 3/8, right? And this will be equal to negative 1/8. So I'm just going to state it here. So you clearly see that the left hand side is not equal to the right hand side. Okay, so associative property will not hold true under subtraction. And finally, let's take one more example to understand whether associative property will hold true under the division operation. Okay, so let's take three numbers. So let's say my first number is 3/5 divided with 2 divided with 5. Okay, so This is my first subgroup, and then on the other hand, I take 3, 5 and then divide with 2, and then that's my first subgroup, and then I divide this whole thing with 5. Okay, I would say that this won't hold true. So let's just demonstrate that. So on the left hand side, what I have is 2 is being divided with 5. So this will be 2 over 5, and this is my first number as it is. And when you actually compute this, this becomes something like this: 3 over 5 times 5 over 2, and that will be nothing but 3 over 2, right? Now let's evaluate the right hand side. On the right hand side, you see that 3 over 5 is being divided with 2, so it will be something stating as 1 over 2, right? And then this whole thing is being divided with 5. This will be 3 over 10 divided with 5, correct? So that can be stated as 3 over 10 multiplied by 1 over 5, right? So this is 3 over 50. So very clearly you see that 3 over 2 is not the same thing as 3 over 50. So this one example is good enough to demonstrate that it does not hold true for division. So what is our conclusion for associative property? The conclusion is that the associative property for rationals, it does hold true for addition and multiplication, but it does not hold true under subtraction and division. And that is exactly what our finding was when we were studying the commutative property, that it does hold true for addition and multiplication, but not for subtraction or division, right? So you see the results are identical in both the commutative and associative property for rationals.